We've been looking up for decades. At Mars, at the Moon, at barren, broken places that were never meant for us. We dream of Mars as our second home, a bold frontier, they say. But what if we're chasing the wrong world? 400 million miles away, orbiting the gas giant Saturn, there's a place cloaked in golden mist. A place with rivers, lakes, and even rain, not of water, but of methane. A world with an atmosphere so thick you wouldn't even need a pressure suit to walk on its surface. It's called Titan, and despite its freezing temperatures, it might be the only place in the solar system that could truly become humanity's second home. Because unlike Mars, Titan protects you from radiation, from explosive decompression, from the unfiltered wrath of space. Here, you could fly, literally, with wings strapped to your back. You could soar over alien valleys. Here, you could harvest the atmosphere itself for energy, for fuel, for life. But why are we not talking about Titan more? Why does Mars steal the spotlight when Titan holds the promise? This is not science fiction. This is real science, backed by NASA, by Cassini data, by planetary scientists who believe Titan is the hidden gem we've ignored for too long. Today, we dive deep into Titan, Saturn's largest moon, to uncover the astonishing reasons why it may not only be more habitable than Mars or the Moon, but more practical, more sustainable, more human. This is the story of the world that breathes for us, and the future we might build, not on red rocks, but beneath golden skies. Titan's skies are thick, thicker than Earth's. Its atmosphere, made mostly of nitrogen, wraps the moon in a dense protective blanket. Sound familiar? It should. Earth's atmosphere is also mostly nitrogen, but here's where it gets even more intriguing. Titan's surface pressure is about 1.5 times that of Earth. This means you wouldn't need a bulky pressurized suit like you would on Mars or the Moon. Just thermal protection and an oxygen mask, and you could walk. No need to fear instant decompression. No deadly solar radiation seeping into your skin. Titan's thick atmosphere does something Mars never could. It shields you. And unlike the Moon, a rock stripped bare by solar winds, Titan holds on to its air. It has winds, weather, even seasons. It rains on Titan. Yes, the rain is liquid methane, not water. But the very presence of a rain cycle means Titan has something critical for habitability: climate dynamics. That puts Titan in a very exclusive club in the solar system. Out of more than 200 moons in the solar system, Titan is the only one with a substantial atmosphere. The second largest moon in the solar system, Titan is even bigger than Mercury. It's a planet in all but name. But size and atmosphere aren't everything. Radiation is the killer in deep space colonization. On Mars, cosmic rays and solar particles rain down without mercy. Even the best suits and habitats need heavy shielding, often underground bunkers. On Titan, the story is different. Its dense nitrogen cloak blocks most of the harmful radiation. Plus, it orbits within the edge of Saturn's magnetic field, giving it additional shielding from galactic cosmic rays. Imagine, you could build habitats on the surface, not buried deep beneath it. You could spend time outdoors, exploring, working, even flying. Now, the temperature is another story. At minus 180 degrees Celsius, Titan is beyond freezing. But that's not a deal breaker. Why? Because in space, cold is the norm. We already know how to engineer habitats that withstand far worse, on the Moon, in orbit, or deep in Antarctica. What matters more is consistency, and Titan delivers it. No massive dust storms like Mars, no violent temperature swings like the Moon. It's cold, but predictably cold, and that, in engineering, is a gift. We can insulate, we can heat, we can build, and Titan's atmosphere makes it far easier to keep that heat inside, unlike the vacuum of space or the near-nothingness of Mars. Here, on Titan, we don't just find protection. We find resources. That hazy orange sky, it's laced with hydrocarbons. Titan has natural gas raining from the sky. Quite literally, energy falling from the heavens. Titan is one of the few places in the solar system where we don't just survive. We harvest. Its surface holds enough methane and ethane to power human colonies for centuries. That's not just science fiction. That's a self-sustaining fuel loop, a dream for off-world energy systems. Between its shielding atmosphere, surface pressure, and abundant fuel, Titan offers what Mars and the Moon cannot. A world that welcomes life, instead of resisting it. This is not just a world we could visit. It's one we could call home. What if the most Earth-like place in the solar system wasn't on the surface at all? Beneath Titan's icy crust lies something astonishing. A vast, global ocean of liquid water, possibly even salt water. That's right. This frozen moon, cloaked in methane, hides liquid water beneath its surface. The very ingredient life requires. We've seen subsurface oceans on moons like Europa and Enceladus, but Titan's is different. It's larger, deeper, and better protected. Thanks to data from the Cassini spacecraft, scientists are confident. Titan has a liquid water ocean 100 kilometers deep, sandwiched beneath its outer crust of ice. An alien sea, untouched for billions of years. Where there's water, there might be life. Not life as we know it, but something else. Something that breathes in methane or thrives without sunlight. Above ground, Titan has lakes, rivers, clouds, and rain, not of water, but liquid methane. This is the only body in the solar system, other than Earth, known to have liquid flowing on its surface. It's a complete hydrological cycle, with methane taking the role of water. This opens the door to alien ecologies. Imagine microbes that use methane like we use water. It's not impossible. It's plausible. And that changes everything. For colonists, this also changes the game. Why? Because fuel is already here. Titan's lakes and atmosphere are filled with hydrocarbons, natural gas. Using simple chemistry, we can turn methane into heat, electricity, and even drinking water. Colonies could power themselves indefinitely. No need for costly shipments from Earth. No nuclear reactors buried under regolith. Just local resources, fueling the dream of interplanetary sustainability. This is what makes Titan unique. It's not just habitable, it's potentially self-sustaining. But the ocean beneath the ice? That's the mystery that grips scientists the most. Could it be warm enough, salty enough, chemically rich enough to spark life? On Earth, life began in deep oceans, around hydrothermal vents where sunlight never reached. Could something similar be happening right now on Titan? We don't know yet, but the ingredients are there. Water, energy, organic molecules, a vast ocean hidden beneath the silence. Titan is not just a place to build homes. It's a place to ask the biggest question of all. Are we alone? On Earth, humans dreamed of flying. On Titan, we could actually do it. With our own wings. Why? Because Titan offers something no other world can. Gravity so low and an atmosphere so dense that a person could take flight, almost like a bird. Titan's gravity is just 14% of Earth's, and its air is 4 times denser than ours. That means a human wearing a specially designed wingsuit could glide, soar, and even flap to fly. No jetpack, no rocket, just muscles and wind. This makes Titan a haven for aeronautic exploration. Imagine colonists not bound by wheels and roads, but flying between settlements, like birds in a slow-motion dream. And it gets better. Because Titan's atmosphere also enables massive cargo airships, long-range drones, and floating science labs. No planet or moon is better suited to airborne technology. NASA's already planning missions like this. The Dragonfly rotorcraft, launching in the 2030s, will fly across Titan, hopping from site to site. And if a drone can do it, why not us? Flying on Titan won't just be practical. It could be fun, freeing, and maybe even a new sport. Imagine Titan's skies alive with motion. Not birds, but people soaring through liquid methane clouds. Low gravity and thick atmosphere also help with agriculture. You can build pressurized greenhouses using local ice and polymers. Crops grow taller, structures can be thinner, and the methane outside? It's perfect for creating fertilizer and synthetic soil boosters. With Titan's resources, colonists could build self-sustaining ecosystems. Imagine vast underground gardens powered by methane fuel cells, protected from radiation, thriving in silence. This is what makes Titan special. It's not just safe, it's usable. You're not fighting against the environment like on Mars, you're working with it. Low gravity also means healthier joints, less strain, and longer stamina. Your bones won't decay like on the Moon. And Titan's atmospheric pressure? Nearly perfect for keeping the human body in balance. With just thermal suits and oxygen masks, humans could walk Titan's surface. No need for bulky, pressurized exosuits like on Mars. That means easier movement, less fatigue, and a better life for settlers. Flying on Titan isn't science fiction. It's physics. It's real. And one day, it may become our way of life. We've flown through Titan's skies. Now it's time to build a world. A world where humans thrive beneath alien clouds, where science becomes survival, and survival becomes civilization. Unlike Mars or the Moon, Titan lets us dream big. Because of its thick atmosphere, radiation is a minor concern. Colonies don't need to be buried underground. Titan colonies could resemble futuristic Arctic towns. Structures made of lightweight polymers, carbon nanotubes, or even locally harvested water ice. That's right, Titan has ice in abundance, and it's strong when compressed or reinforced.
Inside these habitats, life would be cozy and clean. LED farms would provide food. Methane fuel cells would generate power. Titan's own resources would support a closed-loop economy. Titan's methane and water ice can be used to create hydrogen, oxygen, and even building materials. It's not just sustainable, it's scalable. Each settlement could become a self-replicating seed for the next. What about terraforming? Could we one day warm Titan, change its chemistry, make it Earth-like? It's possible, but not anytime soon. Titan is cold, minus 290 degrees Fahrenheit. Warming it would require massive mirrors, greenhouse gas factories, or even nuclear heat injections. And yet, these are real engineering concepts studied by NASA and ESA. But let's not forget, terraforming is more than climate. It's also culture. Colonists on Titan won't just survive. They'll adapt, create, and define new ways to live. Titan's low gravity means you can jump higher, carry more, build bigger. So why not invent zero-G sports, floating sculptures, or cities that hover in Titan's dense air? With time, Titan won't be just a research outpost. It will be a society, a place with its own rules, ethics, and vision. Decentralized systems could govern from day one. Smart contracts, AI-aided law, and remote Earth consultation. Even time will change. A day on Titan is 16 Earth days long. A Titan year is 29 Earth years. Colonists will need a new rhythm, a culture shaped not by the sun, but by Saturn. Imagine the first child born on Titan, the first generation of humans who've never walked Earth. They'll grow up in domes, swim in synthetic lakes, and fly beneath golden skies. And to them, Titan won't be a colony. It will be home. Titan is more than a refuge. It's a blank canvas where we can build not just structures, but a future worthy of our imagination. We've seen how Titan protects us, feeds us, even inspires us. But now, let's explore what Titan offers the solar system. Because Titan isn't just a destination, it's a launch pad, a frontier, a cosmic crossroads. Titan orbits Saturn, the sixth planet from the Sun, deep in the outer solar system. It's far, over 1.4 billion kilometers from Earth, and yet this distance is its greatest advantage. Here's why. Titan's surface is rich in hydrocarbons. Methane and ethane lakes stretch for miles. In spaceflight terms, that means fuel. Imagine future spacecraft stopping at Titan to refuel before heading deeper into the solar system, to Uranus, Neptune, or even the Oort cloud. Titan could become the shell station of the stars. Titan's gravity is just 14% of Earth's. Its atmosphere is thick, which means rockets don't need heavy thermal shielding. And escaping its gravity well requires far less energy. In short, cheaper launches, safer liftoffs. From Titan, we could launch missions faster and cheaper than from Earth. It's the perfect interplanetary port. Titan isn't alone. Saturn has over 140 moons. Some, like Enceladus, have subsurface oceans and plumes, targets for life-seeking missions. From Titan, we can command and explore the entire Saturnian system. It's like setting up base camp at the heart of a treasure map. Titan could host a deep space relay network, boosting communication between Earth and the outer planets. We can place laser-based communication towers on Titan's stable surface, powered by nuclear RTGs or wind turbines. Titan becomes more than a colony. It becomes the internet hub of deep space. The search for life, not just survival, drives us here. Titan's rich chemistry, organic molecules, and subsurface ocean make it a natural laboratory. What if life never needed Earth? What if, in the shadows of Saturn, it began again, differently? Titan gives us a cosmic mirror, not just to see what's out there, but what's possible. A Titan base could help humanity reach the next stage of space civilization, one where we leap from moon to planet, system to system. No longer earthbound explorers, but interplanetary architects. Strategically, Titan is a fuel depot, a launch platform, a mission control center, a research capital, a gateway to the stars. It's the Houston of the outer solar system. One day, when we trace the roots of humanity's expansion into the galaxy, we might not point to Cape Canaveral, but to Titan, a world that was once cold, dark, forgotten, until we saw what it really was, the key to everything beyond. Titan seems perfect. Thick atmosphere, organic chemistry, protection from radiation. But every dream has a shadow. Before we build a future there, we must face the cold, hard truths. This isn't a sci-fi paradise. Titan is also alien, deadly, and unforgiving. Titan's surface temperature averages -179 degrees Celsius. It's so cold that methane and ethane, gases on Earth, are liquids here. Exposure without protection would freeze your body solid in seconds. Not to mention, Titan's atmosphere is mostly nitrogen with no breathable oxygen, and it's laced with methane, highly flammable. It's not just inhospitable, it's outright hostile to life as we know it. Sunlight on Titan is 1% as strong as on Earth. That means solar power is weak and inefficient. Energy must come from nuclear reactors, radioisotope generators, or deep geothermal systems. All are costly, risky, and limited. Titan may shelter us from cosmic rays, but powering life there is a different battle. Yes, Titan has hydrocarbons, but extracting, refining, and storing methane in such temperatures is no small feat. The entire supply chain must be redesigned for cryogenic extremes. And the moon's crust is water ice as hard as rock. Drilling, building, and even anchoring structures will require cutting-edge tech. No sunlight, no greenery, a horizon shrouded in perpetual orange haze. On Titan, humans will face mental isolation like never before. Prolonged stays in dark, frozen environments can lead to depression, disorientation, social breakdown, and even hallucinations. We'll need VR landscapes, simulated sunlight, and social AI just to stay sane. What if there's life already on Titan, hidden in the deep subsurface ocean? Colonizing Titan might destroy alien ecosystems before we even know they exist. Or worse, we might bring Earth microbes that contaminate them forever. We face ethical frontiers just as serious as the physical ones. Should we terraform a world that may already harbor life? And what happens if we awaken something dormant? A Titan colony would be the most expensive human endeavor in history. Each supply launch takes years. Emergency evacuation, nearly impossible. This is a one-way mission with no room for error. The economics of Titan demand international cooperation, shared technology, and decades of planning. And perhaps most critically, political will. We've barely scratched the surface of Titan, literally. What lies in its underground ocean? How stable is the surface? What new chemistry, radiation, or life forms will we uncover? There are things we don't know. And on Titan, that uncertainty is the true danger. Every frontier tests us, not just our strength, but our wisdom. Titan is no exception. It calls us, not because it's easy, but because it will demand everything we are. To reach it, we'll need technology, cooperation, caution, and humility. A frozen moon, cloaked in haze and mystery. Titan was once a distant speck in Saturn's orbit. Today, it may be our boldest hope for survival. But is it more than just a dream? Could it truly become humanity's next home? We are a species of wanderers, driven to climb, sail, and fly into the unknown. Each frontier expands not just our maps, but our very definition of home. Titan represents the next great leap, not just because we can go, but because it asks us who we want to be. Picture it, a network of self-sustaining cities beneath domes, where agriculture thrives under synthetic light. Methane reactors power homes. Humans fly with their own wings in Titan's thick air. Children play beneath Saturn's eternal watch. This is not science fiction. This is engineering, cooperation, and vision made real. Colonizing Titan will require more than technology. It will demand global collaboration on a scale never seen before. No single nation will own Titan. It will be a shared frontier, a place where science, not politics, leads. In a divided world, Titan could become our common mission, the moon that unites us. By going to Titan, we'll discover more than the moon's secrets. We'll discover new chemistry that may rewrite biology, survival strategies for extreme worlds, and perhaps most importantly, a mirror held up to our species. We'll see Earth not as a border, but as a birthplace. Titan will remind us that life is not where we are, but what we carry with us. Every child born on Titan will know a different sky. They will grow in gravity weaker than Earth's. They will learn to fly by muscle alone. They will speak of methane lakes and frozen dunes, not deserts or rainforests. They will be humans still, but shaped by a world not made for us. And that will be our greatest achievement. To plant life where there was none, to raise hope in the dark, to show the universe, we endure. Titan won't be the end. It will be the training ground, the first chapter of a multi-planetary future. From here, we'll reach farther. The subsurface oceans of Europa, the geysers of Enceladus, the atmospheres of exoplanets beyond our sun. Titan is not just a destination. It's a launch pad for everything that comes next. We have the science, we have the drive, we have the vision. Now, we must ask, do we have the will? Titan is waiting, and one day soon, we will answer. If this journey through Titan moved you, if it made you wonder, dream, or question our place in the cosmos, then don't let it stop here. Hit that like button. Subscribe to join a community of curious minds shaping the future. Share this video with someone who needs to believe that humanity still has purpose, still has stars left to chase. And tell us in the comments, if given the chance, would you go to Titan?